Hello and welcome to the second session of our IBM Mobile Quality Assurance Study Group, covering the open beta for IBM Mobile Quality Assurance. And my name is Roger Snook, Worldwide Enablement Leader for Mobile, SOA, and Design. You can reach me at any one of those social media sites, LinkedIn, SlideShare, or even on DeveloperWorks itself. Today's session is about viewing crashes and bug reports using IBM Mobile Quality Assurance. Last week's session, by the way, thank you for all those who completed surveys. Last week's session rated a 4.6 out of 5, so we thank you for your input on that, and I'm glad to know we are delivering the kind of experience you're looking for. Let's see. Let me just get someone the link here. Michael, hold on. And so if you hadn't had a chance to look at last week's slides and recording, you can get them here at this link. And, of course, the slides for today have already been posted to SlideShare. So you'll just search for SlideShare/Roger Snook, and you'll get the content for last week as well. A couple of housekeeping issues. One, this is an open beta, so plans, directions, and futures clearly are subject to change. We are just talking about the context of what's in the open beta today and the capabilities that it has for you today in IBM Mobile Quality Assurance. This call is being recorded, so if you don't like being recorded, please hang up now. We will open the lines for Q&A a little bit later. Today's call really is only going to be a very quick 30 minutes. We'll stay on if there are additional questions and answers that you all want to have done, but this call should be a pretty short one today. So just a brief recap of some of the key facts around this solution and motivation. You know, one of the clear facts here is that today organizations that leverage software development effectively tend to outperform their competitors. 86% of companies believe that software delivery is critical, yet only 25% of those are leveraging that effectively today. But those 25% that are leveraging that effectively today are performing those who don't. In fact, almost 70% of those who effectively leverage software development outperform the competitors. And in the same manner, the same percentage of mobile developers who claim testing and quality assurance is in their top 5 list of concerns, that they're concerned about testing and quality assurance and mobile development, also claim that they're challenged with developing applications as quickly as management wants. You know, it has always been a time versus quality trade-off in this marketplace for developing software. And today, we're going to continue our mobile quality assurance study group to really emphasize that some of these trade-offs can be improved by the fact that we're using automation. Automation to help improve and streamline the mobile quality development that's fundamental to a DevOps lifecycle. And as our customers want to continuously deliver high-quality mobile applications that run on multiple mobile platforms, IBM's Mobile Quality Assurance is a key part in this stage of the DevOps lifecycle, including some of the other tools that you'll see here today, or that you're seeing on the slide right now. So last week we introduced IBM Mobile Quality Assurance. Again, I'm not going to go through the details here. You heard about it last week, but again, those slides are in slideshare.net, and feel free to download those, and the YouTube video is there as well. But today, we're really going to focus on viewing bug reports and the crash reports as well. And these are two of the key use cases that are in this offering. And the provocative question I have for you all is, how long does it take you to fill out a good bug or crash report? You know, bug reports should contain the device maker and model, operating system version, carrier and connection speed or battery life and resolution, and maybe reproduction steps for the bug as well as a screenshot. And when your crash happens in your app, we'd like to have a stack trace to see where that might have come from so we can diagnose and try to pinpoint that error as well as any log information. You know, before mobile quality assurance, really, you're having to enter each of these pieces of information manually, and or you make some conscious decisions about trading off some of that and have inaccurate bug reports for the time that it takes you to enter in all that information. So it's a conscious decision that many development teams make and test teams make to not put in information that might help them better fix bugs. And what we're talking about here is that really when you look at all this information, it might take you about 15 minutes per bug or crash report to gather and input all this information into a form or whatever other place that you're going to be putting that information into. Ideally, that would be something like Rational Team Concert and a work item. That's a defect type of work item. But after MQA, what we're talking about here is really just simply shaking the device, which activates IBM's mobile quality assurance, and the bug details are reported directly into Rational Team Concert. Clearly, there's some annotation and other information that you will type in or punch in on your smartphone, but this is a huge time savings that we believe, again, could save you nearly about 15 minutes per bug. Multiply that by how many bugs you might have reported in any one of your applications, and just to give you a simple benchmark, just 100 bugs that reported through this mechanism could save you about 25 hours. Now that's just one person, one project, and clearly this is something that can add up over time. And clearly it's something, as we look further into this, that the quality analysis that you do after the fact, when all of these bugs and crashes are reported, looking at platform trends and so on, are things that are just extremely time-consuming and that mobile quality assurance can help you with. So in the end, huge time savings. And with that, I am going to transfer control over here to Sanji for the remainder of today's presentation.
Hi everyone, this is and I'll be kind of diving into the crashes and bugs section of MQA, or Quality for Mobile initiative. Can you confirm that you see my screen, a list of issues basically? Roger, can you confirm that you see my screen?
Yeah, I'm sorry, I was just on mute there, so absolutely can see your list of items here. Absolutely.
Okay, great. So as Roger mentioned, MQA is all about giving you context from the mobile runtime. Now, why it's important? It's important because mobile is inherently a very diverse environment, meaning not only the device itself is mobile, obviously, but also there are a lot of fragmentations and a lot of variables that at the end of the day affect the functionality of the application. Okay, it's the quality of our application. So we believe that MQA brings to the table a lot of value only because it's part of the application runtime. So as a tester, while I'm doing mobile testing, it's not only the efficiency and the time saving of reporting the bugs directly from the application, it's also attaching to my bug report, attaching to my feedback, the entire session. So let's dive into what does it mean. So I've logged in as a customer in Quality for Mobile, and I navigated into the bugs section. And as you can see, a bug has three major sections. First of all, there is the actual, click into that, there is the actual device information. So in this case, it's a simulator over Wi-Fi. This is the battery state, though it's a simulator, so it's less relevant. The screen resolution, carrier if available, location if available. So a lot of rich context to figure out what was the framework that the tester used in order to test this application. Now, why it's important? It's important because in many UI issues, for example, especially on Android, the screen resolution plays a significant role. It works wonderfully in the lab on Galaxy S4, but once you go out and deal with all the other screen sizes in the ecosystem of Android, this is where you see rendering issues, UI issues, stuff that as a developer or as a tester within the lab, it's very hard to pinpoint. Obviously, another thing is location. So more and more applications, even in the enterprise world, are location-oriented. And again, trying to test it within the lab is a challenge, but also figure out what was the exact location at the time that I reported the issue and provide that to the developer is also a big challenge if I'm not part of the application. Once we figure out the device framework, you can also see as a QA manager or as a developer what's the length of time that the tester spends in that particular session. Now, why it's important? Because it can help you figure out issues that are related to memory consumption in general. A session that occurs for 30 minutes, you can assume that memory plays a role in it because the application continues to consume more and more memory or logging or any mechanism that you're using as a developer to have an active session with your users. You can also see who reported the issue. Again, everything is within the application, but you still have visibility and can connect the right guy at the right time if you need more information. And the actual SDK version, so the actual MQA SDK version, so it's very clear how we pull that information in case there are issues related to the SDK itself. Now, the device level and user level context, let's dive into the actual session itself. So as you can see here, as a developer, I now have access to all the conditions that happened during the session and all the controllers that were active during the testing session itself. So in this case, I can see that the demo view controller was initiated. So it's kind of the first view of the application. But once I can continue to dive in and see more and reveal more and more of what actually happened there. I can see that the device switched to portrait during the testing session itself. I can see what was the network conditioning at the time. Again, it can be very relevant when the testing is happening within a firewall or within a VPN or within certain locations. Bandwidth is a crucial part of our application, and mobile I/O behaves today. Again, on a simulator, it will work perfect, but once the functionality happens over 3G, and for every function there is a lag time of another 10 milliseconds that the developer didn't anticipate, that can cause a lot of issues along the way. As we dive into the additional information that the session contains, you can see all the controller states that happening during the session. So I really have a good trail track of what caused, at the end of the day, the tester in a bug report to report this issue for me. And once that issue has been reported, I can continue to see what the tester did after the bug report. So it's a very rich logging information that at the end of the day gives me the entire story, and not only we save time for the tester to report the issue, as Rosa said, let's say it's about 10 minutes because I don't need to tether the device and download the log files and upload it into RTC or JZab. This is all happening automatically, but maybe even more importantly, it saves a lot of time for the developer to figure out what was the issue and hopefully fix it in a quicker manner. And obviously everyone likes that our developers are efficient and quick and where it's important, and not figure out what really happened in some testing session in some foreign country. and again, this is another example of a loading problem in this case, and the tester basically highlighting through annotation that it's not acceptable that there is a long loading time in this case. So the combination of runtime logging and runtime monitoring and the human context of what they as users don't like about this particular behavior should produce a very productive dialogue with the developer. So that's the bug reporting side. I will switch now to the crash reporting, and the crash reporting is inherently contains the same structure of information and the same format, but the nature of the information at this case is obviously some exceptions that cause the application to close. So what does it mean? So in general, you can see that we still have the same device information in the same data format. In this case, it's an iPhone application over Wi-Fi with 65% battery. I can see who was the user that actually reported that issue. I can see that we spent 2 hours in testing that application before the application crashes, which can be, again, crucial for me as a developer to figure out why the application crashed. And once I understand that framework, I can dive into the actual session information. So again, format, and I can dive and see the networking condition at the time, and the system and consumption and state all along. And we see a lot of crashes that are around memory warnings. Today, the mobile platforms don't like to, are pretty strict with regards to memory consumption. So once the iOS or Android or Windows Phone identify that you're using more memory than what the OS can allocate for you, the OS will cause crashes on your application. So memory state along the way is a crucial part of trying to understand why the application crashed, and again, it's another thing that is very hard to mimic without having runtime logging. And as I go into the session, and in this case it's a very long session, at the end of the session, basically we would see what caused the actual crash. And we can see that there is some unknown format. So basically the application expects to get a certain variable in a certain format, but they're getting a format that is not acceptable, and which caused that particular crash. And again, before the application closed down, you can see what was the memory and what was the inactive memory. If it was, let's say it was close to 0, then I would know that memory is the problem. But in this case, it's probably not a memory problem. And if I'm diving into the stack trace itself, I can see all the logging information that the developer choose to log out as part of the logging, as part of the iOS logging mechanism in this case. See all the elements that were involved in that crash. In this case, those are all the static elements. And what was the last library that was loaded before the application closed down. Now, how that crash ended up on the MQA side, basically before the application closed down, because the MQA is part of the application, we basically bind our SDK to the exception handler of the application. So we capture all that information, save that into the local storage of the device, and the next time the tester we load the application, the first thing that the SDK will do is report that crash report into the MQA server with all the context that I just presented.
So, Roy, if I may, please, because Hamid asked a kind of a related question. What happens if the bug report submission fails due to the lack of reception or any other reason? Is there any automated retry? Does the user get notified? I know you're talking more about the crash right now, but in this particular instance, it could apply to both.
Yeah, it's a good question for both. We do have mechanisms to, let's say the phone is offline, so we are not able to connect. We do have a mechanism to continue to store the crash report or the bug report locally and try to submit it next time there is initiate activity. We will do it to a certain threshold, meaning we don't want to collect a lot of information on the local storage for too long. In our case, is more than 100 kilobytes, because we don't want to affect either the networking of the application or the local storage of it, or the memory consumption of it. So the answer is yes, but at some point in time, we would flush the memory if we see that for more than 100 kilobytes, we can send them to our servers. Any other questions around that area?
Let's see, Patrick then asked, does MQA run inside a company's network in order to send the crash reporting, or is it a public internet-facing site?
So the beta version is a cloud offering, so it's something that runs on a hosted environment. In our case, it's on Amazon AWS. But as we go to GA, there would be an on-premise version of it. So that really means that all the information that is being collected from the mobile runtime, either in test or in production, will end up in your enterprise environment.
Thanks, Roy. Appreciate it.
One other thing I wanted to highlight, obviously we're all mobile users, and as mobile users, I'm sure you as me experience a lot of crashes all the time. So one of the other features that MQA provides is really a clustering of crashes. So MQA mission is all about development efficiency. So we want to help the developers work on genuine information and making sure that they have all the context to improve their application. So we basically analyze all the stack traces that are being reported from the mobile application environment, and we try to correlate crashes to one another. And so it's important because we don't want to notify the developer for the same crash report again and again and again and again, because it kind of defeats the purpose. So in this particular example, you can see that this unknown format was recorded 29 times. So as a developer, not only I know the context of the crash, I also know the implication of it. If it's a crash that happens once on some device that represents 0.2 of my customer base, that's one thing. It's one set of priorities for me. But if it's a crash that happens 29 times after 10 minutes that build was in the hands of testers, and I see it happens on iPhone 4S, which represents 35% of my customer base, that's a whole different story in terms of prioritization, so I should probably fix that first. And that's really part of the vision of MQA as well, is try to correlate as much as possible all those moving parts to make you the developer manager or the QA manager smarter about the data that you consume from the mobile runtime.
Yeah, I think adding to that, Roy, I think we've seen customers that have a particular crash that might be unique to a particular platform, and through that analysis, you can, examine some of that detail and find out if it's something that might be specific to a particular platform or particular memory condition or what have you, and thus revealing, perhaps a better way to fix the problem. And some of those are the intangibles of the value that you might come up here with.
Yeah, exactly. A very typical scenario, once the dev team hand off a build to testing, and let's say after 24 hours they want to know, okay, what's going on, a very typical scenario would be, let's go to the crashes list, and let's start with the crash that happens the most often, and try to figure out what's the priority there. And from our experience, in most cases, those items would be the first thing that they will fix. Because if a crash happens pretty frequently, it means it's probably on a popular device because the testing team try to represent their market in some shape or form. Or it just happens across all the environments, and in this case, obviously, I do need to fix it as soon as possible.
Excellent. So, Roy, we only have really 2 minutes left for the half hour. We can stay on for additional questions, and I see Patrick has one more question here. But if you wanted to just throw those slides back up for a moment, and then we can go into any additional discussion immediately afterwards. But and you would just stop sharing in your that little tab that's overlapping the top there. Just do a stop sharing.
Yeah, I just did.
Great. And these slides, you can certainly address some of these slides here as we go along. But basically, you showed this in-app bug reporting and the ability to look at some of the detail behind that of the information that was presented. So these slides are here for your reference as well, and shows you some of the details about what you can see in those crash log reports. We already had the demonstration. Again, our study group is here at that landing page, and the action items after today are really, once again, take the brief survey, let us know how we're doing. If we need to do something a little different, we want to hear from you. There is a new MQA tutorial video created by our CTO, Lee Williamson, and highly recommended to check that out. And then, of course, just for reference, if you haven't already jumped into the MQA Open Beta, the landing page for that is there as well. So please join us there. So next week, we'll talk about connecting the mobile app end users and the developer environment in, again, our brief session. But the question that Patrick had is MQA data transmission from the device to the server. Is that done through SSL?
Yes. So the protocol between the SDK, between the mobile runtime and the MQA servers is a proprietary protocol, fully HTTPS based. So yeah.
Excellent. All right.
And by the way, that's true for both. We didn't touch the production side of things in this particular session. We talked about it a bit last week. That's true for both production and pre-production. So MQA can run in production as well and give you the same rich information, mainly about crash reporting that happens in production. And again, that information is also being transmitted over HTTPS. And
I think the true simplicity of the solution lends itself to what we're hearing right now, which is no question. So I think at this point I'll conclude the call, and I want to thank you all for attending. Again, look out for the survey, give us some feedback on the session, and please join us for next week's session as we connect the end users with the developer environment. Thank you, and have a great day.
Thank you.
Thank you.
Thank you.